Okay, folks, welcome to week 3. Um, we are going to be talking about conceptual diagramming pretty much for today. So we get to learn how to draw pictures. And let's see if I can, oh no, it's not going to do that. I'm going to have to click on the slides. All right, so let's get rid of this. I hate the fact that I have to leave the slides, like that. But anyways, it is what it is. So database modeling. Database modeling is the process of creating diagrams, essentially, so that there is a blueprint of the structure of your database. And there's 3 kinds of common diagrams. There's the conceptual diagram, the logical diagram, and the physical diagram. Now, for the conceptual diagram, there's 2 kinds, the traditional and the extended. So in the 1970s, I think it was roughly, this data scientist called Peter Chen created something called conceptual diagrams. This is known as the traditional diagram. It's very basic. It has 2 symbols. And then a little bit later, people said, yeah, but you're really not catching the whole, nuances of this. So they added more symbols to the diagrams, or at least different flavors of the same symbols. Then we had something called the logical diagram, which is basically a more detailed version that includes data types and primary keys and that kind of stuff. And then the logical diagram type is supposed to be portable between database systems. You have a logical diagram and it should be applicable to any database server. It's not specific. The physical diagram is where it becomes specific to the engine. That will use the specific data types, some of the special structures the database server would have, maybe some of the naming conventions that it enforces on you, some of the limitations, that kind of stuff. The physical diagram is exactly how it would be. I don't know if has anybody here ever looked at house plans? You go to a website and they show you house plans. It's just a bunch of lines that shows rooms and labels. You can think of that as a logical diagram, because when you order the actual plans, they'll actually ask you what jurisdiction you're in, because they'll send you plans that are applicable to whatever jurisdiction. So, for example, you order house plans and you live in Nevada, US. The plans will be very different than if it's a plan being shipped to Quebec. Why? The requirements for the studs in the walls are different. The electrical is different. So the plans change. Even though you're starting at the same base plan, the end destination changes how things are done. That's the physical. All right. I already covered half the slide. So the original diagram had 2 symbols, as I said earlier, squares and diamonds. Entities are squares, relationships were the diamond. So in this case, we have 2 entities and 1 relationship in this example, which is a person, location, and the relationship is birthplace. So a person is born, location. There was a notation they used back then, which was the 1N or M. And normally, if it was a 1 relationship, which, I did describe to you guys, 1-to-1, 1 student, 1 locker, you would have a 1 and 1 on each side of the diamond. So the symbol goes to whatever side. Now you'll notice that what's on this side is how this one is related to this one. Whatever notation's on this side is how this one is related to that one. So the end of the line, so if you look at an object and you follow the line, whatever's above the line is actually how it's related. So a person can only ever have 1 birthplace, but hopefully most places have more than 1 person that can be born there, right? Therefore, you have 1 to N. You'll also have MN, many to many. You might have 1-1, 1-to-1. I've also seen it done as 1M, as in one to many. It just sounds, a little bit up to you. I've also seen M because some people just like to differentiate the two halves, even though they mean the same thing. M for many, N for a number of, I guess. Uh, it's just many. Um, yes, they just mean many. It's just depending on how you're applying it. Some people will choose to do NM, other one will do MM. But the good news is they came up with a better notation for that problem. So, but that's what it was in 1976. So this type of diagram is only 1 year younger than me. It's 49 years old. So, um, over the years, the chance cell diagram evolved and was given extra symbols. Things that were added. Attributes. Kind of know how to describe something. They added attributes. Different symbols for different kinds of entities and relationships. Um, Different notation styles for the relationships. Once these were added, it became known as an extended conceptual diagram. Okay, attributes are represented by ovals. I wonder if I can just zoom in. Is it gonna let me zoom in? That's better. Okay, attributes are ovals. So, or earlier you saw, you had a box, a diamond, and a box. Cool. However, sometimes you want to describe this thing, and one of the big benefits of the conceptual diagram is you can take it to someone who's non-technical. You explain to them what the two or three basic symbols are, and they can read the diagram. There's other things you can add on, like fancier versions of each of these, but at a base level, I could take a conceptual diagram, take it to an executive, and explain to them what the data structures are with pictures that are not complicated. Executives are good at what they do. They're just often not very technical. So they like things simple. Yeah, yeah, you keep things simple because kids learn. Um, so they decided, cool that we have attributes, they're ovals, but we also realize that, things are nuanced and there's more than one kind of attribute. We have identifiers, also known as primary keys. How do you put those into a diagram? You underline it. If something is optional, you can put in a parentheses with an O to say it's optional. So in this particular thing, the student number is the identifier. Their phone number is an attribute that's required. Their cell number is optional. Derived attributes, because when you're doing the initial design phase, derived attributes are allowed to exist. A derived attribute is an example of one of those is the person's age. Because when a value can be calculated based on other values in the database without external input, that's known as a derived attribute. For example, now minus your date of birth tells you how old you are. Mathematically, that's how you do it, right? How many years from the day I was born to today, or how many days, how many minutes, how many seconds, whatever. Now minus date of birth tells you how old something is, or a person is. However, at the design stage, you might want to keep track of the fact that, we want to know how old a person is. So you could put in what they call a derived attribute, and you put it in a dashed circle. So instead of being a solid circle, it's dashed to represent the fact that it's calculated. A composite attribute, and there's a typo in my word, parenthesis. They're contained in a parenthesis. You may or may not choose to explode it to its component pieces. My favorite example of a composite attribute is an address. A lot of people go, what's your address? And the person will 123 Sum Street, Ottawa, Ontario, K1TU, blah, 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 right? However, you're actually purveying at least 4 pieces of data. A street address of some sort, the city, the province, the postal code, and depending on what you're doing, country. You may have two lines for street address, right? 123 Sum Street, Suite 100. Two pieces of information. That's known as a composite attribute. At the design stage, it's cool that you have it as one thing because you're trying to explain to management that we're going to hold an address on this student table. They don't want to think about how the address is broken down. Developers care a lot. End users will care. So you put it in with parentheses and you can have ovals tied off of it. So in this case, we have an address and we have all the independent pieces off of it, off the side. Exactly. So when this gets converted to a database table, you would drop this address, but you'd create all four of these instead. So when this becomes a physical diagram, these become the attributes. But at the design stage, when you're trying to explain, we just want to track an address, you can just put in a composite attribute with the parentheses around the name of the attribute, saying this is made up of many things. So at a glance, you can see it's made up of multiple things, and we need to deal with this later. So after they were finished expanding the concepts of attributes, they said, well, we might need some new symbols for entities and relationships. So weak entities are identified by a double box. So we had the box before for an entity. A weak entity has two boxes. Why they pick two boxes, I have no idea, but it's two boxes. So if you recall when we talked about loans and payments, a loan would be one box, the payment would be two boxes because the payment can't exist without the loan. It's a weak entity, double boxes. Associative entities are identified by a diamond in a box. An associative entity is the one that lives between, it's the middle of the many relationship. A good example for that would be like an order line. An order line bridges an order and products. And that would be an associative entity. So you'll notice it's a box with a diamond inside of it. Because it's saying this is an entity that relates to other entities. So it's being used to resolve, a complex relationship. And the last one we had was identifying relationships. They have double diamonds. So identifying relationships have to do with weak entities. So they said, for two boxes for the weak entity, we'll use two diamonds for the identifying relationship. Again, payment, loan, and payment. A payment can't exist without the loan. It can't be identified without the loan identifier. Therefore, the relationship between them is identified. Honestly, I'm pretty sure in the labs, Safraz will be happy with just single diamonds. just saying. But I will actually be demonstrating you guys what all these symbols look like in a bit with the tool you're going to use to actually draw these diagrams. Don't use draw.io. It's terrible for this. There is a tool that was actually written by some professors at some university. And it's actually like the best diagramming tool I've ever used. Normally you hear, created by professors at some university means it's a piece of crap. I'm just calling it the way it is. But I'm guessing they had some really good undergrads that did all the work for them because it's a really good tool. And it's still being improved. So they've added a few features recently and it's pretty decent. Hey? Well, those three are the extras. Realistically, the ones you need to worry about is the box, the diamond, and the attributes. Will cover pretty much everything you need for the labs. When Safraz assigns you the lab next week, because he's 1 week behind, just verify with him what level of detail he'll want. I'm going to try to remember when I get home to send him an email, say, hey, by the way, hey, Safraz, want them to do like this, all the special symbols, or are you going to be happy with all the basic symbols? But if I don't remember, verify with him. He did send me an email yesterday to verify I covered normalization, so we're communicating. It's shocking. So now that they gave us new ways of diagramming how the relationships are, kind of the relationships with kind of entities, what the attributes are, they realized that Chen's notation was weak. You'll notice it's the same year as the Chen style diagrams on this slide. So in 1976, this guy called Gordon Everest wrote an article that goes, Chen style relationship notation sucks. We need to come up with something new. And it basically it ended up creating something called crow's foot. Crow's foot is pretty much industry standard, except in Brazil. I don't know why, but Brazilians decided to do it with ID1 fix. It's a different format. It's a different syntax, and I don't get it. It actually uses like half-colored boxes and stuff. It's just weird. Everybody else, pretty much everybody else in the world uses crow's foot. So, and the cool thing about crow's foot is it covers every major piece of information you need about a relationship. It covers something called cardinality. Cardinality is how many instances participate in the relationship, one or many. So it says, is this a one-to-one, one-to-many, many-to-many? It's got a symbol to tell it one or more. Optionality. Is this entity required? In other words, is a child record optional or mandatory? Is the parent record optional or mandatory? For example, you place an order with Amazon. The minute you check out, they don't know how, well, they probably do, but it's not set yet what shipping method they're going to use. Are they going to use Amazon shipping? Or are they going to use FedEx? Are they going to use Canada Post? Are they going to use, they're called Dragonfly now, but it was whatever, the magic punters, Intelcom, back in the day, who'd just punt your parcels across the yard. When you check out the order, the shipping method is not set on your order yet. But each item can only ever be shipped with one shipping method, therefore the relationship is optional. And it's one to many. One shipping method, many parcels, but it's optional. So each end of each relationship line will have two markers. The good news is you only ever need to remember 4 symbols. There's 4 symbols that do it all. And these are the 4. You have one and only one. That means that the first line closest to the object means how many. The single line means 1, and this is why it's called crow's foot. The little 4, so you have 1 or many, right? 1 or many. It's visual. And then the next symbol next to it is 1 if it's required, 0 or O for optional, right? So this means 1 and only 1. That means there must be 1. Back to our student and lockers. Which that's really stupid because students don't barely rent lockers anymore. But let's pretend you were required to rent a locker. That would mean that you are allowed to have 1 locker and you must have 1 locker. The next one down is 1 to many. An order, pardon? Yeah, sure. So a prof must have at least 1 student and can have many students. So it's 1 or more. The other side is the optional. 0 or more. For example, when you enroll here at the school, you are enrolled as a student, but you have not been assigned to any courses yet. So as a student, you can exist in the system without any courses assigned to you. So at that point, you can have 0 or more courses. That also means 1, right? Sometimes a lot of people, like myself, I do it too. So I usually write it out as 0, 1 or more, just to make sure that it's completely obvious that 1 is more than 0, but there could be more than 1. So it's 0 or more. I tend to write it 0, 1 or more. That's just me. And the other one we have 0 or none. Back to the student and the lockers, the real way. A student can only ever have one locker, but you don't need to have a locker. The locker is only ever assigned to one student, but it might not even be rented for the semester, so the locker has 0 students. This is saying that at most there's allowed to be one, but there's the option to not have any at all. Those are your 4 symbols you need to remember. Memorize these 4 pictures and life will be good. And here's just another example, A has 0 or 1, so it can only ever have 1, but it might not have any. And this B can have 1 and only one A. A must have at least one B, but could have multiple B. And in the last one is B can have many or none. That's another example of rewriting these samples. Here's a pro tip though. Inside the physical database, there's no such thing as optional many and mandatory many. It's all optional many. Why? Chicken before the egg. So when you say it's mandatory 1, so you have an order, okay? And the order must have one product for it to be a valid order. Fairly straightforward concept, right? It's not a valid order unless there's something in the shopping cart. Imagine you go to Loblaws to check out, you go, I'm checking out, and you have nothing in your cart. It's impossible, right? It's not how it works. However, in the database world, the order must exist before you can buy it, before you can add a product to the order. So it's same thing at Loblaws. When they start a new transaction, they cannot add anything to your receipt unless they've started a new transaction on their point of sale terminal. Their system is written in such a way that it always defaults to new order. Please add something. But that order exists already, and then it adds things to it. So realistically, instead of the database server, one-to-one, mandatory, one-to-many, mandatory, optional many-to-many, or optional, one-to-many, they're all optional one-to-many. Even one-to-one is optional one-to-many. Physically inside the database server, these are concepts for when you're setting up the rules of how your data behaves. They're conceptual concepts. When you do the physical diagram, it's still going to be like that, but it's so that developers understand that, one order, one product, a product can't belong to multiple orders. Like, imagine you have your shopping cart and you go, okay, see these bananas? I want to buy them, and the person behind me wants to buy the exact same bananas. You can't do that. They can buy their own bananas, but they can't have your bananas. As far as their system's concerned, you know, bananas. Okay, right here. The symbols are all on this diagram. All right, so here's 2 sets of examples. This shows you everything you need for the labs in one slide, okay? So we have our student entity. I already described this stuff, right, when I kept the little arrows. And we have courses, correct? And the course has a course number and a description. And the student's allowed to be enrolled in multiple courses. Now, the course enrollment's a weak entity because you can't have an enrollment without a course and a student. It cannot exist without either of those, so it's weak. Imagine you could enroll a course and you don't have a student. Like, it cannot exist without it. And these are identifying relationships. And in here, some people will write the 1 to M, just, whatever reason. But when you diagram it, you'll notice that for the course enrollment, the student is only, because it's an associative entity, by the way, a student can be enrolled in many courses or not enrolled at all. Like I told you guys, you put into the system, but you're not assigned any courses yet. So the student can have 0 or more courses, but any given enrollment can ever belong to one student and one course. For example, each of you are in CST8250 lecture 1 time. This section. So, there's one extra layer here, but 1 time. You can be in 8260 or whatever other courses you're taking this semester one time at each. But this course can have multiple students. That's literally what this is showing. Okay, so you'll notice that the symbols are at each end. So the symbol that describes the relation of student to course enrollment is at this end of the line. The symbol that describes how the course enrollment connects to the student is at that end. It's just like the original diagram where you had the 1 and the n, except now we have, symbols instead of letters and numbers. So whenever you look at a relationship, whenever you want to figure out how this is related to this, you always follow it from the source entity to the end. Whatever symbol's at the end of the line is the one that applies. And over here we have another example of optional on both sides. You have an order, hasn't been shipped. A shipping method may have 0 or more orders tied to it because maybe we just got a brand new courier that we've never used and we haven't shipped a single order yet. So it's optional. An order gets created, but it hasn't been shipped yet, so we don't know what courier we're going to use, so it's optional. An order can only be shipped by one courier, but a given courier can carry many parcels. Okay? Same thing with the product to the order line. You'll notice the order line is an associative entity because the difference between an associative entity and there's a word, and I can't remember what it's called. It's not important. But over here, there's two versions of this. And the difference is that between an associative entity and whatever this other one's called, is that the associative entity will have extra columns. Intersect table, that's what the other one's called. So let's just say all you have is order and product, and all you have in that other table is the primary keys of the other two tables. Order ID, product ID, no other information. That's known as an intersection table. All it does, it maps one to the other multiple times. However, an order line maps one to the other multiple times. It also includes things like quantity, sell price, shipping date. So any entity that does the intersection between two other entities that has more attributes in it is known as an associative entity. It associates two tables to each other, but it has extra magic sauce inside of it. Okay, so characteristics of a good conceptual model. It provides a high level overview of the system to be built. Like it shouldn't be super detailed. The point of the conceptual diagram is a rough sketch. It's supposed to explain all the big pieces, but not get bogged down in detail. It's also a blueprint that can be referred to throughout the entire project. In other words, as people work, they can refer to this to make sure that, they're designing things in a way that makes sense. A good conceptual diagram should avoid technical consideration or terminology. Technical consideration is Oracle uses varchar2, Postgres uses character varying, MySQL uses varchar. They're all the same thing, but those are technical considerations because each platform does something different. It prevents it from being locked to a particular database system because it should be generic. It can be used to get feedback from non-technical users. If your diagram is straightforward enough to be able to give it to a non-technical person with a minimal explanation and they can say that does not make sense, or that does make sense, or yes, you've got the right idea, it's a good diagram. And it should give you a good starting point for creating logical and physical models. Okay? Now, remember last week where I did that last example with the genres in the books and the lending and stuff? We're going to diagram it today. We're going to take last week's lecture material and then we're going to apply it to today. Okay, so launch my browser, erdplus.com. I'm pretty sure lab 1 required you to go register here. Log in, log in. Okay. So, this is new. See, I'm talking about they're adding new features. Apparently we got a new feature. That wasn't there last time I logged in. All right, so in here, you have your typical file management system with multiple folders and that kind of stuff. I'm going to click New Diagram, and you give it a name. Lecture, not lecture 325 summer, create. And then you open it. Blank canvas. Probably the simplest looking diagramming tool you've ever seen. It has like half a dozen buttons. So let's just say I want to add a new entity. You click on entity, you click on the diagram, and here's our entity. Over here, we give it the name. So if I go back to here, we go genre. Let's start with genre. Genre. So here's my entity. It holds genres. Let me go see if I can zoom in a bit. Yeah, I don't think I'm going to be able to zoom in much more because I'm not going to have room to work. Okay, on this, we can add attributes. The genre ID. And in this one here, it doesn't call it candidate key, it calls it unique. My idea. You click it, it's a line, just like the example. I'm going to add another attribute, and this one was the genre name. And I'm going to leave it alone, just like that. I'm going to add another entity. Which one's my next one? Author. And I'm going to go author ID, and that's unique. And author name. Okay, put this one here. One of the reasons why this is such a good tool, like .io, did you just notice what just happened? It just happened so naturally, you probably didn't even notice. I'm going to grab the entity and look, it takes its attributes with it. It moves it as a single unit. So when you're moving things in your diagram, it moves it all together. Try doing that in draw.io and tell me how well that goes. It's going to move that one object and you have lines everywhere. Whoever decided this is how it was going to behave was fantastic. Absolutely. Now I'm going to create my borrower table. Borrower. And I'm going to add an attribute. ID. Add an attribute. Name. Like that. Now we're going to add a book. Like this. We're going to add an attribute of book ID. Book title. And that's it. So one of the things about conceptual diagrams is you don't normally put in the foreign keys because that's a technical consideration. You're worrying about the foreign key. However, you will do the connections. So then you have this thing called connect. So, or actually relationship. So you click on relationship, you click on one, well, basically you drop it, and then you can go entity one is a genre, entity two is the, and now it has that. Now, if we want it to be identifying, you can hit the identifying. That's just a design consideration. You can decide if it's mandatory or not. So this is saying that genre is mandatory and can be applied to many books. Each book must have at least one genre. And now we go, if I go connect, is it going to drop it for me? Yes. So if I did a connect, it just draws a relationship for you instead of you having to pick it. Okay. The author is mandatory many. And this is mandatory one. Okay, so some of you might be wondering where I'm picking mandatory many as opposed to optional many. Is a book must have at least one author. It could have like most, but they always have at least one author. So therefore, it's a mandatory, and it gets option 0 or it's a 1 or more. Okay, And now we have one last entity to put in, which is the, what did I call it? Bookland. Book lend. Okay. And we are going to connect. No, not that. We're going to connect book to lend and connect borrower to lend. You can actually give it a nice name if you want. You want to actually give a nice name to it. Now, the book lend is a weak entity, right? It cannot exist without a book and a person borrowing it. So it's a weak entity. So we can say that this is an identifying relationship because it is. And the book is mandatory many, but this one is optional one. Actually, no, it's mandatory one. This example, actually, everything's mandatory. Not enough sample sizes to actually have all the other kinds. So this is saying that a book can be borrowed once or many times. The book can only ever be borrowed when a person is borrowing the book. They can only borrow the one copy of the book, and just the one time. And I'm going to make this one also identifying, and it's going to be mandatory many and mandatory one, just the same. Now this one is a weak entity, but it's technically also associative because it associates. So this is where you suddenly have to make a decision. Which one do you want to use? Or do you just want to be lazy and just go regular? You can use all three. All three are valid. It depends on your case. I'm going to make it an associative entity because it has attributes of its own. It's not just a relationship. It's a table that associates two other tables. It has a little bit more of its own personality. Because if you remember right, it's got the borrow date and the return date. So now we got an attribute, and we add another attribute called return date. And this is last week's normalization example diagrammed. So you can take that sample table, clean up all the data, and then you can make a diagram, and now you can go to the management with saying, that data you gave me, this is how it actually breaks down as pictures. Because management likes pictures. They're not fond of complicated explanations. All right, so one other thing on this tool you'll want to do is put in a label. Normally in here, you'd put in your, student, and it just puts a box. It's a little gross, not character turn, but whatever. You can do multiple labels, one label, whatever makes you happy. And there that is. Save automatically saves it. Now, when you go to submit your labs, or if you want to use this tool and in your job, you're not going to take a screenshot. Don't be that student. When it's got the tool for it, it's called export image. So you tell it, don't do transparent background, because if whoever's looking at it is using a dark mode, they're not going to see the relationships because it's just going to be like circles and white boxes and circles and no lines, right? So leave it like this. It's cool if you want to go high resolution. If you go save, it downloads it, and you have a nice diagram to submit for your work. And it's, pretty high res. It's actually really big, actually. It's, if I go 100%, honestly, you could just do normal size when you submit it, because that's, 4 times. But yeah, so this is this tool. If I remember right, so physical diagram, vertabello.com, which is the other one you guys are supposed to set up an account in. And when you log in, brings you like this. Oh, here's lecture 4. but I'm actually going to do a little bit of I'm just going to show you guys how to use this tool. Um, so again, it's like the other one. You go new diagram, physical model, next. Pick your flavor, and since we're working with MySQL, you are going to pick MySQL. You give it a name, lecture 3, start modeling. It is. And you add your table, you give it a name. Uh, I'm only going to do 2, just I'm not going to do the whole thing. I'm going to go with genre. And here you tend to want to follow your naming conventions, whatever it is. And you will want to add columns first. So I'm going to go genre ID. And actually, instead of just adding primary key here, you can hit the checkbox. It'll do it for you. I'm going to add another column, which is the genre name. And this one's a varchar 50. There you go. I've got a table. It does it for you. I'm going to add another table. Book. And I'm going to add a column here called book name. But actually, book ID first. And it's primary key. And don't use spaces in your table names. Very bad form. And book title. Again, and again, I put a space in. Varchar 100 because you just don't want to assume. Okay. Now you'll notice that I didn't put in the foreign key. Because at this point, you normally put in the foreign keys. That's because it has a tool for that. And I'm going to probably get this one backwards because I always get it backwards the first time because I use so many different tools and they're all a little bit different. You see right here, it says new reference. So you click on one table, drag it to the other table. Oh, I did it in the right order. So click on the parent, drag it to the child. And you will notice that it created your relationship for you. You'll also notice that it added the foreign key for you automatically. Now oops, I want to stop doing that. Back to this. Um, you'll probably want to rename your foreign key. Just saying. You probably want to rename it so that's a little more reasonable. Um, you'll only thing about this particular application, it doesn't do the the optional until you get it just right. There's a few other things in here you can. There's whatever. If you want to make things pretty. Um, again, the other one you'll want to put in is a label, which I think is it this one? That's an area note. 0, 1, 2, 3, 4, 5, and there's my name. So then you want to export as a PNG, all of it. Hit generate and download. And now we open it. And here's our diagram. Again, don't use screenshots because as your diagrams get bigger and more complicated, they take up more room, and then people think they're being clever, so they zoom out, take a screenshot, and everything's this big for the teacher, and we can't actually read it. So do an export. You can also choose to export as a PDF. Uh, generate and download, and you can also submit it as a PDF. And the PDF, of course, is vector, so you can zoom in, zoom out to your heart's content, then you're fine. So that's how you use Vertibello. It's like any other diagramming tool, but it's made specifically just for database. Um, the cool part about this tool, though, is also will generate SQL, ignore warnings, download, and edit with Notepad++. And here's my DDL. It'll create your database structure for you. And you can see it even creates the foreign keys. It saves a bit of typing. If you diagram it properly, you can export it. And it will export the SQL to be platform specific. So it'll do the flavor for MySQL or Postgres or Oracle or whatever. If I were to change the target on that diagram, which I think I can, come here and change this to Oracle, yeah, 21C. Okay. And then this is, close that, leave varchar 50 like this. And if I were to generate the SQL for this, ignore warnings, download, and come here and edit with Notepad++. Here's the Oracle flavor of this. It looks fairly similar. You'll notice that some of it's a little different about how the syntax is laid out. You'll see, like, it's slightly different. But it does the flavor specific to the platform. It also has, if you're working with other platforms that support it, if I bring this back to MySQL, save, and we take our key and we expand this, we can also go additional properties, is it? No, not that. Here, auto increment, which is not letting me set it to auto increment. I don't know why. Set, there we go. Auto increment set to yes. It'll do the auto increment for you. So you can do it all in here and do a nice diagram. You don't have to think about the syntax for your target. It'll do the conversions for you, which is nice. So that is how you use Vertibello. Over the years, there's been the odd time where Vertibello doesn't play nice, just falls over. There are other tools you can use. MySQL Workbench, you can download it and use it. Mac users, your mileage will vary. Just warning you now. MySQL Workbench and Mac has a rocky relationship, but it is a download, drag and drop install. But every once in a while, just the icons disappear and you have to learn the keyboard shortcuts. They just go away and they never come back. Yet to know why it does that, but I just blame Oracle for that. So, because Oracle's the one that created that. But yeah, so that's everything I needed. 1 hour. They got the courses backwards where really the level 1 should have 2 hours and level 2 should have 1 hour a week. There are later it takes a little more than the hour, but it's a diagram. It's fairly straightforward concepts. Okay. Does anybody have any questions before I call it up? Call it. Going once, going twice. Okay. Because I couldn't see his face. I just saw a head and hair. So I'm like, let's make eye contact. We're good. All right.